In this video, we are going to learn about surds, what are they and how to operate on them. That is how to add, subtract, multiply or divide. Okay, so let's get introduced to surds. So first of all, what is a surd? A number or expression with a root which can't be written as a rational number. So now, if we are talking about something with a root, for example, if I write root 2 or root 3, we know that root 2 or root 3, they are not perfect squares, right? I can't convert them into rational numbers. They can never be in p by q form because they are non-terminating and non-repeating decimal values. They are always going to be irrational. So these kind of numbers are called as surds. Over here in the definition, I had written a number or expression. The examples that I have just given you is only for numbers as of now. However, if I write root x plus y, this is also an expression. So this is also a surd, okay? Because I can't convert that into p by q form. Therefore, this is a surd. Now, let's get introduced to the operations on it. Now, the first thing we need to talk about is addition of surds. Over here, what you can see on the screen is some examples with respect to variables, because I will explain how to operate on surds with the help of variables. By class 9th, you are already aware and easily comfortable with on addition, subtraction, multiplication or division between different variables, right? So that is why I'm going to explain with the help of them. The first example is 2x plus 3y. Now, when we are adding the like variable, what we do, we add their coefficient, right? So the answer comes out to be 5x. X remains as it is, but we just added the coefficients. Now, similarly, if I add 2 root 2 plus 3 root 2, now what we have over here? We have got the same root, right? So what we will do over here, we are just going to add the numbers written outside the root. These numbers are the rational parts. So we will add the rational components and we will get the root just besides them. So 2 plus 3 is 5 and we will have root 2 outside. I will take another example. Let's say if I have minus root 5 plus 7 root 5. Now, when I just write minus root 5, what exactly it means? It means I have minus 1 over here, right? So minus 1 plus 7, that gives me 6. So my answer is going to be 6 root 5. That means when we have same root, we can easily add the rational numbers written outside. Okay, now next example on the screen, you can see we have 3x plus 2y. In variables, we know that we cannot add different, that is unlike variables, right? Similarly, when we talk about surds, we cannot add different surds. Now, for example, if I write 3 root 2 plus 2 root 3, we can't add them anyhow because the roots are different. So the answer just remains as it is. This is the most simplest form and we cannot do anything further to this one. Okay, this is how the addition of surds takes place because we can't operate on them when they are different. However, we can easily add when they are same roots. Now, let's move on to subtraction. In subtraction also, I have given a similar sort of examples using variables. So let's understand this quickly. When we are having 7x minus 4x, what do? We subtract the coefficients of x and the answer comes out to be 3x because we subtracted 7 minus 4 and just wrote x besides. Now similarly, if I have 7 root 3 minus 4 root 3, so what I'm going to do? I'm going to subtract the rational component, which is 7 minus 4. This comes out to be 3 and the root comes along, that is root 3. So the answer is 3 root 3. Let's take another one. If we have 11 root 5 minus root 5. Now, the first rational number is 11. The second rational number is 1. When you do not see any number before the root, it means it is accompanied by 1 being a rational number. So what we do over here is we subtract 11 minus 1 and this comes out to be 10 root 5. So the subtraction is also pretty easy as the way we had addition. Now, let's talk about the second example wherein I have written 8x minus 3y. There are unlike variables, right? You can't do anything to them. They remain as it is. In the similar manner, if I write 8 root 2 minus 3 root 5, now what do we have over here? We have got different roots, so we can't subtract them. And hence, this answer, this statement remains as it is. You cannot simplify or you cannot do anything to it. Okay. Now, let's move on to multiplication. In multiplication also, I have given examples over here with respect to variables. So let's understand them. The first one is 2x times 3x. When we multiply variable with variable, what happens? We multiply the coefficients. Along with that, we also multiply the variables. So the answer over here comes out to be 6 because 2 times 3 is 6 and x times x becomes x square. So the answer over here is 6x square. Now similarly, if I write 2 root 2 into 3 root 2, what happens? We will have 2 into 3, that is 6, and root 2 into root 2 becomes square of root 2. Now, please understand over here, when you are doing a square of a root, the root and the square will void each other. In detail, you can understand it. You are multiplying root 2 with root 2, right? Now, we can rewrite this as 6 times root 2 into root 2. I have clubbed them in the same root. This becomes 6 times root 4, that is 6 into 2, and therefore this answer comes out to be 12. However, this is just to explain you, but I will recommend always do not get into these steps when you are squaring a particular root. What you can do, you can just write the answer directly over here, 6 times 2, because root and square gets cancelled and you get 6 into 2, which is 12. So always try to use this short method instead of getting into the longer steps when you are squaring a root. Okay. Now, the next example underneath, what we have over here is 11x into 5y. There are unlike variables, but multiplication is possible in unlike variables, right? So what do we do over here? We will multiply 11 into 5. It becomes 55. And we also multiply x into y. It becomes xy. Now, let's understand with respect to surds. So we have 11 root 2 into 5 root 3. Now what do we do? 11 into 5, that is we are multiplying the rational components, becomes 55. Root 2 times root 3 can be written as like this, and hence your answer comes out to be 55 root 6, because unlike roots or different roots can multiply with each other. So answer becomes over here as 55 root 6. This is multiplication where we have learned that whether they are different roots or whether they are same roots, they can multiply with each other. Okay. Now let's move on to the last operation, which is division. Okay. In division also, I have given two examples over here for variables. First example where we have like variables and the second where we have unlike. So let's start. The first one is 12x divided with 4x. Now, what do? We can rewrite this as 12x divided with 4x. So x and x got cancelled. 12 and 4 will become 3. So my answer is just 3 over here, right? Because there were same variables, they cancelled out. Now, if I write 12 root 2 divided with 4 root 2. Now, writing this into fractional form gives me 12 root 2 over 4 root 2, right? So now, root 2 and root 2 got cancelled. 12 over 4 will divide, and hence I get the same answer over here as 3. So here we learned how the same roots can divide. Now the last example on the screen, we have 10x divided with 5y. Okay, now we have different unlike terms over here. We will divide 10x with 5y. 5 and 10 will cancel out, it gives 2, but x and y will remain as it is, and my answer comes out to be 2x divided with y. Now let's understand with respect to surds, but I'm sure by now you must have understood what is going to be the answer. So now I'm taking an example. If I have 10 root 2 divided with 5 root 3, right? What do we get? We will write in the fractional form, and we have 10 root 2 over 5 root 3. So 5 and 10 will divide each other, but root 2 and root 3 will remain as it is. So my answer is going to be 2 root 2 over root 3. This is the final answer over here. So in this video, we understood what are surds and how to add, subtract, multiply, and divide them, right? I hope everything is clear. In the next video, you can find that how do we do all the complicated questions with respect to the operations on surds together. Okay. Till then, happy learning.